my talk. Yes, here we go. Um, I was sharing a flat over a shop with a couple of other students in Surbiton for Kingston Polytechnic in the early 70s. We did a lot of weird student stuff, like the electric toilet flush that signaled to the world when it was being used and could be operated remotely for giving surprises, and the Meccano rover that ran up and down the pavement of the main road, and the model railway that ran around the flat. We thought it would be fun to buy a scrap computer to play with and let schools, researchers, and ordinary people come and use it for their own projects. I'd already, there were emerging hardware designs, and I had already made an adding machine using old Stroger telephone parts, but wanted something better to really use. We wanted to link it by radio to Croydon Astronomical Society's observatory. We'd looked at an Elliott 802 computer with Mercury delay line and a PDP Whatsit, and got to know the surplus electronics trade and the world of 5-track paper tape, but nothing was quite right, not a proper machine. It was a surprise when I had a phone call and visit from ICL engineer Rodney Brown, who said London University would be scrapping a machine due to be replaced by something newer. Rodney said it was a bit big, but has everything necessary and there's scope for adding attachments of our own. Just the job. It was in their administration building, Senate House. Big, wow. We visited Senate House and saw Flossie in action. Apparently it was serial number 6, the first ICT 1301 out of the factory in 1962, and had been a prototype intended for internal software development. But the university said there'd be no student intake that year without it, and the president of the Board of Trade, one Harold Wilson, got ICT to reassign the machine, and this does show in its modification history. So this is both the first and now the last of its type. And depending on who you ask, it cost 68,000 or 750,000, although the list price for the range went to 250,000. I understand it boasted the first proper commercial printer. Anyone my age, your GCE certificates were printed on this very machine. The students never got near it. It assigned student accommodation, ordered pencils, etc. And the printer was carefully adjusted each year to optimize the appearance of certificates. Intended for general commercial work like payroll and accounting, it might be the programmable tabulator that Babbage wanted. By 1966, when production ceased, nearly 200 of these machines had been made and sent all around the world. The one in Poland was paid for in tractors. Despite its ridiculous size, conceptually it's rather simple. It runs a single program at a time, then stops for the operator to feed the next one. It's made with discrete germanium transistors. They're the two blue things. Depending on which one is turned on, can be said to hold a 0 or a 1. Stack several of these binary flip-flops side by side to assemble a binary number with many bits. On the 1301, 48 bits form a word and is distributed over 4 shelving racks for doing the calculations. 48 bits holds a number as big as a million, which can be your company profits, or alternatively might be computer program instructions, which are also stored simply as numbers. The numbers move about as directed by program to achieve the calculation or any input-output wanted. What makes this machine worth saving is the reliable construction methods developed by GEC for building telephone exchanges, where instead of plug-in cards, the joints are wire-wrapped, and with 5,000 cards, they need to work. The machine has now been moved at least 6 times with no really fatal problems, and has plenty of spare parts acquired from other machines, so we're confident it will run again. Apparently, in 1971, we were only competing with scrap dealers for the price of the metal, and the university was pleased to see it going for educational use at a price of £200, buyer collecting from Senate House. We'd spent a few days camping in their basement while we dismantled it. We studied the manuals and knew more or less what we were doing by then with help from friendly ICL engineers. The memory is a mixture, firstly of magnetic core store with 2,000 words or 12 kilobytes in modern terms. Having a clock rate of 1 megahertz, it's called immediate access store. Then there's the magnetic drum store, where a rotating vertical cylinder with a magnetic oxide coating is surrounded by stationary read-write heads. It's a bit slower than core store and is used to hold a copy of the current program or overlays of data like lookup tables that don't have to be in immediate access. With 12,000 words or 72 kilobytes, one drum is enough, but we did add a few more later for fun. At one government site in London, I was told that a drum which needed changing had to be dismantled and the oxide washed off in case it contained sensitive information. The modest amount of memory in kilobytes, not megabytes or gigabytes, is plenty when there's no graphics or media to manipulate, just data records. And the programs can be quite small while achieving a lot because there's no operating system in the way. The programmer has complete control, writing straightforward machine code that can modify its own instructions, which are, as we said, just numbers. The clock speed of 1 megahertz is pushing it for the germanium transistors of the day, with program instruction times being measured in microseconds, while anything mechanical like the printer is working on a millisecond scale, 1,000 times slower. So a program is comfortably able to keep all the gadgets running simultaneously if it wants. The third type of memory is magnetic tape for permanent storage of data files and programs, as well as making a scratch pad for larger intermediate results. Flossie came with 4 tape transports. We added several more later from other scrap machines. It is capable of using 8 at once. From London University in 1971, we hired a lorry and moved it to a heated double garage in Sutton while we looked for a permanent home. Estates of post-war prefab houses were being dismantled. You could get one of these for £200 delivered in sections, and there was just enough room in the back garden of our student flat. After we bought the lease, pulled down 2 derelict workshops, arranged planning consent, barrowed a couple of lorry loads of concrete down the narrow passage which was the only street access, and still is incidentally. The council made us add an internal brick wall for soundproofing, and there was a lot of fuss about obtaining 3-phase mains. There was a great party for our helpers in the empty room. By now we had formed the Galdor Company (Electronics Limited), trading as Galdor Computing. My colleagues, Andrew Keane, Derek O'Dell and myself, Stuart Fife, were studying electrical and electronic engineering. Others came to our flat or lived nearby, notably Trevor Jarrett, Dirk Koopman, Don Hedges, Chris Hewitt, Adrian Barnes, Steve Garnett, and later Peter Singleton and John Skeen. The name Galdor is a minor character in The Lord of the Rings, which I was reading. A funny thing, we asked for an ordinary telephone line and without prompting were given 399 1300. I took this as a sign we were doing something right. Moving the machine to Surbiton in another tail lift lorry was easy enough. The most time-consuming part of installation was, of course, reconnecting thousands of wire-linked joints between the bays by half a dozen people helping in their spare time. Here, Andy deals with an awkward corner, and instead of wrapping joints, we decided to solder them. There's no risk of making a wrong connection. It's all one-to-one links. The design is ideal. It is a lovely machine to work on. The first power on was not a success. No smoke, but the clock waveform was all over the place. This derives more or less from simply amplifying a drum track. It turned out that the motors were rotating in the wrong direction, including the drum. We fixed that by reversing a couple of phases on the three-phase mains. Now we just had to find where any faulty circuit boards might be and anything else that wasn't working. Fault finding was pretty easy because there are test points everywhere and the diagrams are faultless, identifying every pin and wire. And the test programs are pretty good too for identifying problem areas. With multiple faults masking each other, it did take some months to commission the machine. Here, Rodney uses engineer's controls in the blue sections of control panels. The state of most internal sections can be observed and changed from here. It could take a day to pin down a subtle fault in the tape system, but we would learn a lot by the end of it. When it has settled down, there's a fresh fault only about once a month. We replaced individual transistors when there were no spare circuit boards of the right type. You couldn't do that with an integrated circuit or even TTL logic. Here, Fido is helping me try some program ideas. The room was comfortably warm for our resident cat, with 5 kilowatts from the machine and double that when the peripherals are running. It's so big that air conditioning is unnecessary beyond an extractor fan. The mechanical parts are nice to work on too, being well made with heavy castings and oil-filled gearboxes. Lovely stuff. Having unbuffered peripherals is annoying, but it does keep the price down. This means the main program has to loop and wait for the printer barrel to rotate to the next letter you want to print. This can all be concealed in modular program subroutines from a standard library. Here, lights shine through a slotted wheel in the printer. Apart from what came with the machine, spare parts were obtained by dismantling other 1300s wherever we could find them, with our troop of friends and a big lorry. We also added 8-track paper tape reader and punch and picked up a variety of punch card preparation machines. Parts get all over the place. The BBC props department used to have a console. It turns up on Doctor Who occasionally. Students, friends, researchers, schools and reporters came to see us. Some were puzzled, some stayed. Modifications are easy to make on the 1301. There are gaps in the instruction codes that can be used. You just have to add some gates to decode the instructions and do something interesting. Ordinary arithmetic instructions like addition are available in sterling as well as decimal, achieved in the electronic mill with automatic carry between pence and shillings, shillings and pounds. Handy before the UK currency was decimated in 1971, 50 years ago, and I still think in shillings and inches. It's done by messing with the overflow from one digit to the next, which is how binary coded decimal works anyway. It just needed 10 and 11 to be made as single characters in the printer and was standard on all 1300 series, avoiding software solutions to an everyday problem. However, we added a switch to treat the Sterling instructions as plain 48-bit binary, which was sometimes more useful. The original clock pulse generator was improved with a phased lock loop circuit, which proved more stable. And we added an instruction to index or modify other instructions. One practical change was adding buttons on the console to clear an entire register in one go without first dialing up lots of zeros. We altered the original bootstrap program called Initial Orders, which lives on reserved tracks of the drum, to add extra things to its link loader cleverness, like unload all the tapes, or run sequentially any number of programs unattended by reading a single punch card, then finding the required program on a library tape, instead of having the operator feed lots of punch cards containing each program each time. Also, we use the drum store to sort files into ordered chunks before involving slow tape-based merge sorts. Sorting was needed because of the linear way records are kept on magnetic tape, there being no random access disk drives. My colleague Andrew Keane can take credit for much of this sort of trickery. It's a mystery why such things were not supplied by ICT, as it was not that difficult. This is a lovely machine for hardware and software tinkering, making an excellent teaching resource. We held open days and school visits, giving hands-on experience in computing fundamentals. But most activity was with customers who appreciated our low overheads. We wrote programs to look after club and society membership and subscription lists. It was called ClubSoc and used by some 35 organizations eventually. Nowadays, they do it all themselves with PCs, but in the mid-70s, a cheap bureau service was ideal. It started with London Village and went on to include UK administrations of Amnesty International and Friends of the Earth, and Town and Country Planning Association, the Legalised Cannabis Campaign, and Vol magazine, to name a few. The data was punched onto cards by a separate bureau, and we would produce lists and mail-out labels. We also produced biorhythm charts for a client, and later on produced the complex administration for the annual Southern Counties Cat Fanciers shows, with each cat entered in several classes for judging. An attempt was made to generate schools' timetables by machine, but the complexities of split sites and individual pupils' requirements meant this project was not a real success. As the only independent go-to place for 1300 help, we provided standby processing and tape conversions for other sites and did a 6-month period of continuous contract operating at Liverpool Victoria Friendly Society in London, culminating in round-the-clock shifts while they converted to 1900 series. Their 1301 machines were Samantha and Arthur, and had suffered a Y2K type crisis when insurance interest rates reached 10%, suddenly needing 2 digits. This was before our time, but rang large in the department's folklore. When the Arthur machine retired, we helped move it to a friend's farm in Kent. Galdor did enough to keep the business running, buying scrap machines to use, progressing through the 1900 series, which contained useful amounts of reclaimable gold. We used COBOL and George III and moved to bigger premises with a 1905E. I left Galdor when the fun went out of it, moving to Wiltshire in 1981 as engineer, programmer, and help desk for some curious retail software. With space needed for other things, Flossie had been moved to Kent in 1977, eventually replacing Arthur, which was demoted to spare parts at Bus Farm. You may know Bus Farm better as the home of Pop Larkin in the Darling Buds of May series, where exterior scenes were filmed. Roger Holmes had a big task getting the machine together. A bird's nest was found in one of the electronic bays, rubber insulation and degraded components were replaced, and he had other calls on his time, so progress was erratic until 2002, when engineer Rod Brown, who we mentioned earlier, heard about it and got involved again. Then, with further help from the Computer Conservation Society, there was enough ready to have an open public day in 2004, coinciding with the annual Darling Buds of May Classic Car Show in an adjacent field. Each year, more of the 1301 was working for car show open days. To make space, Arthur was sold to Mike Armstrong and taken to Timeline Computer Archive Museum, Cumbria, where it is now on display, but unlikely to run again. Numerous engineering sessions brought Flossie to almost full working condition, and visitors were fascinated by its story, experiencing the sights and sounds of the running demo. We believe it was the oldest working and original second generation stored program mainframe computer. And on days that the Harwell Decathlon or which was off air, ours was the oldest working original of any kind in the world, although various replicas and rebuilds abound. 2013 marks the end of this phase as the farm was sold and the 1301 donated to the National Museum of Computing, Bletchley Park, along with full documentation and plenty of spares and software, where it now sits in their large warehouse alongside all sorts of curious gadgets. Some work has been done at Bletchley to read the program tapes offline and curate the material, but the planned installation as an operational centrepiece exhibit is on hold, awaiting funds to construct a space. It is particularly suitable for hands-on teaching of hardware and software from first principles, watching the effect of individual machine code instructions on the console lights, and tinkering with the covers off, and ought to be pretty reliable on account of the robust construction. A convincing fake display could be arranged, whirling some tapes and lighting up the console without turning on the machine at all. And who knows, it might appear again in science fiction films. Working around Flossie was one of the most satisfying things I've done, and much credit goes to the designers. Yes, it was my birthday last week. I was born on the day that discovering the transistor effect was announced in 1948. What a long way we've come. And now a short video presentation from Bus Farm in 2012.
$12, and now down the bottom end, 9, 8 and 7.
She was originally installed at the University of London. When it came to the end of its working life there, a bunch of students bought it. They operated it as a bureau service for some time. They decided to move on to more modern machines, and they put an advert in the Amateur Computer Club newsletter.
It represents to me a piece of solid British history that people worked very, very hard after the war to bring into reality. This is a significant piece of equipment, and it's the only one left in the world working today.
Yeah, so there we are.
Stuart, that was absolutely fantastic. I think we should have a round of applause, really. Unfortunately, everyone's muted, but that was absolutely amazing. I mean, not only was it a fantastic project, but it was a great presentation and a fantastic, thing that you've done there.